Okay, so over the past couple days, we have been working with the derivative longhand. Some of you, when we did the chain game, might have been able to figure out, hey, there's some tricks to these. So today we're going to learn what the tricks are for different types of pieces. So our first rule, or our first trick, is the constant. So if I take the derivative of a constant or any number, the derivative of that is 0. So if you notice on these rules, I have the typed word, so the wording of what it is, and then below it is the mathematical example. You don't need to write both. If you want to just write the mathematical part, that is excellent. Do you get to just write the word part? No. Reason being is you need to get used to seeing this notation. So therefore, please at least write this part. If you need to write both, great. Go ahead and pause the video when you need to. I will be going through these semi-quickly just so we can get some more practice. So again, constant, the derivative of a constant is 0. Power rule. The derivative of x to a power is going to be n times x to the n minus 1 power. So what that's saying is I have x to some exponent, say 4. I bring down that exponent, and my new exponent will be that whatever that value is minus 1. So if I had x to the 4th, I'll have 4x to the 3rd. Constant multiple rule. That is where the derivative of c times a function is going to be c times the derivative of that function. So what I can do is basically factor out whatever that constant was and then take the derivative of that function. So if you notice here, I see f of x and I see f prime of x, or x, excuse me, or f apostrophe x. That notation is saying that I'm taking the derivative of whatever that function is. Now remember, functions are some sort of equal sign with an expression. So for example, x squared, y is equal to x squared minus 2 plus 3. So finding the derivative of that function. The sum and difference rule. So this is a twofer. The first part talks about if you take the sum of two functions. So the derivative of f of x plus g of x is going to be the derivative of f plus the derivative of g. So that's saying that I can distribute that derivative through, and I can find the derivative of f and then find the derivative of g. And then go ahead and add those two functions together. The second part is the difference. So if you take the derivative of f minus g, that is the derivative of f minus the derivative of g. So same idea. If I'm trying to originally find the subtraction of my two functions, I simply find their derivatives first and then subtract them. Derivative of sine and cosine. So I have said over and over and over again that sine and cosine are the main parts of finding anything to do with calculus. That being said, they also have derivatives, and yes, you'll need to know these derivatives. So the derivative of sine is cosine. The derivative of cosine is negative sine. So the way I always remember these, or attempt to memorize these, is sine equals cosine, cosine equals not sine. So cosine is to negative sine, sine is to cosine. So, or I always think if I'm changing it to sine, I need to tack on a negative. Just like all the other rules, this is something you just need to memorize. So I would get used to it or start memorizing it, however you memorize things best. Okay, so let's go ahead and put this into practice. So I have the derivative of 5. So I'm finding the derivative of a constant. So the derivative of a constant, if you recall from the first one, is just going to be a big old 0. So we have a nice good old donut hole on that first example. Alright, well if you take a look, I have another constant for my second example. So the derivative of that will also be 0. Well, now I have x to the 5th. So this is the power rule. So that's saying that I take down that x value of 5. It becomes a coefficient. Then to find the new power, I take whatever my old power was minus 1. So the derivative of x to the 5th is 5x to the 4th. So for these examples, I also have power rule going on. I have x to the 17th, which means I bring down that 17. So I have 17x to the 17 minus 1 gives me 16. So that derivative of x to the 17th is 17x to the 16th. The second example, I'm going to bring down that negative 3. So I have negative 3x to the, now negative 3 minus 1, I always will subtract 1 no matter what my exponent is. 3 minus 1 gives me that negative 4. So then I have negative 3x to the negative 4th. Well, I do not like negative exponents, so I'm going to keep my negative 3 on top, move my x to the 4th to the denominator, and that's going to be my answer. Oops. Same idea, power rule. But now I have a 5 in front. That 5 is going to stay there. When I bring that 4 down, it's going to come down with multiplication. And I'm going to have x to the 3 because 4 minus 1 is 3. So I'm going to do a little simplification. 5 times 4 gives me 20. So my derivative is 20x to the 3rd power. Same idea, we have another example of power rule. So I have 3 times 7 x to the 6th. 3 times 7 gives me 21. So my answer is 21x to the 6th. This middle example, you notice you have a lot going on. So this is where it comes into the finding the derivative of multiple things in a line. So this is finding each derivative. So first things first, I'm taking the derivative of 5x squared. So I bring down that 2. So I have 5 times 2. X to the 2 minus 1 gives me 1. The second piece, I have negative 7x to the first. So negative 7 times 1 gives me negative 7. Then I have minus 1, which is going to give me an exponent of 0. If you recall your days of exponents, anything to the 0 power is simply 1. So whenever I take the derivative of a single x with a number in front of it, it's just going to be that number. So say I was finding the derivative of negative 3x, the derivative of that is just going to be negative 3. Because again, you bring down that multiplication of 1. 1 minus 1 gives me 0. Anything to that 0 power is 1. If I go back to my example, this gives me a nice old 0. The derivative of a constant is 0. So I don't need to add 0 because we're all aware that anything plus 0 is just itself. So I keep simplifying. I get 10x minus 7. Let's try this one. So I'm going to bring down this 3 with the 6. So I have 6 times 3. X to the 3 minus 1 is 2. I have that invisible 1 there, so 1 times the negative 5 is negative 5. 1 minus 1 is 0. Anything to the 0 is 1, so therefore it's just minus 5. 6 times 3 gives me 18. So I have 18x squared minus 5. Alright, couple more, and then I think we are finished after this. Yeah. Okay, so if you look at this first example, I have my x in the denominator. Well, we talked about earlier making negative exponents positive by moving it down. So this is the same thing as x to the negative second. If that numerator was anything besides 1, then I would have that value in front of the x. So if it was a 2, then I'd have 2x to the negative second. Because again, only the x is in the denominator. So I'm going to bring that down. So I have negative 2x to the negative third, because negative 2 minus 1 gives me negative 3. I don't like negative exponents, so I have negative 2 over x cubed. In the second example, I have 2 times sine of x. So what I can do is I can find the derivative of sine of x and then multiply 2 with it. So the derivative of sine is equal to cosine. So I have 2 times cosine of x, which just gives me 2 cosine x. This next one, I have that invisible 1 up top for my exponent. So that 1 comes down. 1 minus 1 gives me 0. Anything to 0 disappears, so I just get 1. The derivative of cosine is not sine, so it's going to be negative sine of x. So my answer here is 1 minus sine x. This next example, 2 times 2 gives me 4. Sine is equal to cosine. So I have 4x plus cosine of x. Alright, go ahead and do your homework. I'll see you tomorrow.